In this video, we're going to solve this question from the 2023 MIT Integration Bee. What is the integral from 0 to half pi of x cotangent x dx? Then how to solve this problem? We're going to simplify this integral first. So let's see. So here the integral from 0 to half pi, then x cotangent x dx. First, let's rewrite cotangent. Then here 0 to half pi x. For cotangent, we put as cosine x over sine x. Next, we're going to combine cosine x with dx. That's just d of sine x. So next we're going to combine 1 over sine with d sine x. So that's d log sine x. So now we can use the method of integration by parts. Then here just x times log sine x. Then the lower bound, upper bound. Then minus the integral. Then this part. So log sine x, then dx. So now let's look at this part. So if we plug in the upper bound pi over 2 here, sine pi over 2 is 1. Then log 1 is 0. So then this one is 0. So now let's plug in the lower bound here is 0. So that means this part just equals 0. So now let's see this part. Because for this integral, just log sine x, so this integral is not easy to get an answer for. So we're going to denote this part as I. Then here just minus I. Then just equals negative I. So that means we start from the original integral. So now we have this one. So let's write down the results so far. So here's the original integral. Then just here x cotangent x dx just equals the negative I. So we can label this one as a result 1. So once we figure out I, we're going to put the answer back here. Okay, so now let's work on the integral I. So the integral I, just from 0 to half pi, then here log sine x dx. Because here we have a sine x. So now let's look at the graph of sine. So here, just from 0 to pi. Then in the middle, that's half pi. Then here, then this is a sine curve. This is sine. So from this graph, we can tell, so the integral from 0 to pi is twice the integral from 0 to half pi. Because the sine curve in this interval is symmetric above half pi. So that means this integral is half of the integral from 0 to pi. So then here, half of the integral from 0 to pi, then here, log sine x dx. So next, we're going to do a substitution. We're going to define x equals 2t. Then solve for t equals half of x. So now let's do the substitution. Let's continue this equal sign. So then here, 1/2. So let's see the lower bound. When x is 0, t is 0. Then when x is pi, then here half pi. Then inside is log sine x use 2t for x. Then here dx, then just dt, d2t. Then let's simplify. So take these two up front, then cancel out with 1/2. Then here just the integral from 0 to half pi, then log. So then inside the sine of 2t. For sine of 2t, we use a double angle formula for sine. So then here sine 2t just equals 2 sine t cosine t. Then here dt. So let's look at the inside. So inside the log, we have a product of 3 terms. So then based on the property of log, so log of product equal sum of logs. Then here just equals just the first one, log 2. Then plus log sine t. Then plus log cosine t. And here dt. So next, we're going to do a substitution. We're going to use x for t. So we're going to separate this integral into 3 parts. So let's see the first one. Because log 2 is a constant, so then for the first integral, just pi over 2, then log 2. Let's see the second one. Second one from 0 to pi over 2. This one. So log sine t, we use x, then dx. Then the next one, the integral, then here log cosine x dx. Okay, so now see here we have 2 integrals. So let's see what's the difference between them. You see here, this one is a sine, this one is a cosine. That is the only difference. So now let's look at the sine cosine curves. Now let's see here. So this one here from 0 to half pi. Then in the middle there's pi over 4. Then here, then this is sine curve. This is sine curve. So now let's see the cosine curve. Then here, that's cosine curve. So you see for sine curve and cosine curve in the interval from 0 to half pi, so they are symmetric above pi over 4. So that means the area under the sine curve, this part, equals the area under the cosine curve, this part. Again, because they are symmetric above pi over 4. So what that means, so that means for these 2 integrals, they are equal. So that means for these 2 integrals, we can put as following. Just equals the first part, half pi, then log 2. Then for these 2 integrals, we can put a 2 times this integral. So the integral from 0 to half pi, then log sine x dx. Again, here we put twice of this integral. Okay, so now let's look at this one. So this one, just the one we defined is I. So that means here we got this one. So we have here pi over 2 log 2 then plus 2i. Okay, so now let's look back a little bit, because here we are using a very useful method in calculus. You see here, we started from I, then we made some changes. So now we end up with the expression containing I. So that means now we have an equation for I. So now we have this equation. So I equals this expression, half pi log 2 plus 2i. So now we just solve this equation for I. So then here I just equals negative pi over 2 log 2. So now let's mark this result. So then by result 1, so this is result 1. So the original integral x cotangent x dx equals negative I. So this is result 1. So now we have an answer for I. So we can use this part to replace I. So then here just equals negative pi over 2 log 2. Negative cancelled. So the answer just pi over 2 log 2. So then pi over 2 log 2 is the answer for this integral. Thanks for watching.